Assalamu alaikum warahmatullahi wabarakatuh. Hope you all are doing very well. So today, since we are starting this computer science 9618 syllabus 2026 onwards, so the first chapter, let's start straight away. First chapter we have in this subject content for the AS level is the information representation. This is the first chapter in all the books usually in the hot, especially the hotter books. Some books are arranged according to their own understanding, not according to the syllabus. Okay, so let's move on to chapter 1.1, which is data representation. The how do we represent data? How does the computer represent data? So we learn all of it in this chapter. First of all, we should be able to cover the syllabus because usually in the books there are some things that are usually out of the syllabus or some things that are not explained so well. So the good idea would be that we are very well prepared for the syllabus for whatever is demanded from the syllabus. Like since they always say candidate should be able to do this, do what, we should be able to do that thing. Once we are able to, and we practice a little of passive verbs, so we will be good enough to get an A star. Start is in this the first 1.1. The first point that we are supposed to be doing is show understanding of binary magnitudes and the difference between binary prefixes and decimal prefixes. So first of all, I hope you all have done some in the high school, the secondary school. We already studied something. Maybe O level geometric. We know what is binary, what is binary. Binary number system is a base two number system number system that the computer communicates in. For example, the computer has if you go deeper, computer and the CPU and all the computer case that we have that deals in that deals by gates that we have, for example, AND gate, OR gate, NOR gate. Okay, so that can have only two cases, on or off. Some gate can allow some data to pass through, which will indicate that it's on, or if it doesn't allow, that will indicate it is off. Okay. So that's what we have. So in this case, the same way the computer, so we can say computer communicates in binary language, which is 0 1 0 1 0 1. You will see great number 0 1 0 1 1 0 0 0. So that may mean something that we cannot know. But denary is something. Denary is the language usually we use. Denary is a base 10 number system, 0 to 9, 0 1 2 3 4 5 6 7 8 9. Okay, so these are 10 numbers that actually denary number system consists of. Those are the numbers that we usually use in our daily life. Okay, so what are prefixes? For example, so what do I mean by a kilometer? Kilometer, I mean by there's a measurement called meter. Okay, it's a specific measurement. Okay, so what do I mean by kilo? Kilo means 1,000. So what do I mean by kilometer? Surely that means 1,000 meter. Okay, the same if, for example, if I say million, what do I mean by that? I mean the prefix that is there in this, the prefix, the prefix that is there in the million, that is mega. Okay, which is 1 and 6 zeros that it has. Okay, the same way binary also has. For example, you go to the shop and say you're going to buy mobile, so you know it's 128 GB. Okay, you know what does GB stand for? GB stands for GB bytes. Actually, we in our daily lives we call it GB, but it's actually GB. We write actually the way like this way. For example, what actually 128 GB is. Okay, there are some. It's really the talk of the town. So we are supposed to correct this thing. It's 128 GB. That it has 1024 into 1024 into 1024 bytes that are available for storing something storage, the secondary storage that we have really. Okay, so now we just need to know this prefix is it. So syllabus demand from us is that we should be able to show understanding and the difference between binary prefix and the decimal prefixes. So we already understood the binary prefixes are used for computers and the bytes that are stored on the computer, while Then the prefixes are used, the decimal prefixes that we also call it, are used for the our daily life communication and the physical quantities that we have. Okay. So what is kb, what is kilo, what is maybe, what is mega, what is gb, what is giga, what is tb, and what is tera. That's in the notes. So this is a comparison that's made. A kb, with the value of kb is 1024 and kilo is 1000. Okay, then maybe is just multiplied of the same number, just it's the square, 1024 into 1024. Okay, that becomes 1048576 something. Okay, and here is that mega. So for example, let's say you have a mobile that has a RAM of 20, for example, 8 bytes. Okay, so what are you going to do? That means one 8 by 8, if it's 8 bytes, so 8 into 1024 into 1024 are the number of bytes that that the that it has the RAM of. For example, one time you can have as many applications that use 1024 into 1024 into 8 bytes. Okay, so this is the reference. We just need to memorize these. This is actually using calculation that we will be practicing later on. Okay, so we are done with the first one. Okay, the practice is remaining. We will be doing that soon. So next demand is show understanding of different number systems. Would use the binary, ternary, and hexadecimal number basis and BCD and ones and twos complement representation for binary numbers. Now we have already studied what is binary number. We already know what is binary from our secondary schools, and so but we can still go on writing the definition again so that we remember it again. It's actually binary is a base 2 number system that the computers communicate in. Okay, and what is binary is a base 10 number system okay, and what is hexadecimal number system is a base 16 number system that are used by computers for ease of human understanding. For example, just suppose what if there's an error that contains this, for the most minimum case, for example, it has only 2 letters, that would be for example, it usually use 6 bytes 16 bytes, sorry, 16 bits, that means 2 bits. So if it uses 2 bits, I mean 16 bytes, so what would that mean if it represents in binary numbers? So that would make up something like 16 bits of such a long text that will be written on a screen. But if we have the other way around, if we use hexadecimal number system for displaying errors, okay, so you must have you must be very familiar with the error code. For example, if you log into some website or you surface some website, there's an error 404 not found. So what does 404 mean?